In problem number 1, if the interest rate on an account is 11.5% compounded yearly, approximately how many years will it take to triple the amount? What we're basically saying is we want the ratio of the future value to the present value to be equal to 3. So if we were to say, all right, F, P, I%, N, we want this to be equal to 1 plus I to the nth, and this is equal to 3. The unknown in this problem is N. So we take the 1 plus 0.115, that's the interest rate, raised to the nth power, this is equal to 3. So that N times the log of 1.115 must be equal to the log of 3. You can solve for N from this. N is equal to 10.09 years. So it takes approximately 10.09 years for the future value to be equal to 3 times the present value. Problem number 2, somebody put $1,000 in an account 15 years ago. Today, it's worth $2,370. We know that the bank pays interest twice a year. What is the nominal annual interest rate paid on this account? Well, the value of P, the present value, was looking back 15 years ago, was equal to $1,000. N would be the number of compounding periods. We actually had 15 years, and it did it twice a year. So N is equal to 30. And so we can get the future value by taking the value of P and multiplies by F, P, I%, N. Now the unknown in this problem is I. We don't know what the interest rate is. Now this is 2370, the value of F. The value of P is 1,000. And then we have a discount factor. And so a discount factor, F, P, comma, I%, comma, N, that this then must equal 2.37. But 2.37 is equal to the value of 1 plus I raised to the 30th power. So if we solve this equation for I, either by going to a table or by looking at or using a calculator, we find that I is equal to 0.02918, or if you like, 2.918% would be the effective rate per period. But the nominal annual interest rate will be twice this amount, so you have to multiply this by 2 to get 5.8% as the nominal annual interest rate. And I believe that was the question, what is the nominal annual interest rate paid in this account? 5.8%.